Lowering the barriers in space travel is one of the most important challenges the space community is facing. Another barrier is choosing what to wear. A daily challenge for most of us and a multi-million problem for the space industry. We're not talking about fashion, of course. Astronauts can take only like 3 shirts and 2 pairs of pants, right? So we're not talking about that. We're talking about space environment protection. AstroRad is an anti-radiation protective suit based on selective protection that has been developed to protect the astronauts on their way to the Moon and Mars. In prolonged missions, radiation in these areas might damage their function, and in the long run, they might even be fatal. Eitan Steve wore the AstroRad during his time on board the ISS, but I think we're all interested in hearing about the AstroRad and the Moon. The suit was part of an experiment on Artemis 1 mission to the Moon that came back to Earth just over a month ago. Today, we'll be the first to hear the conclusions of the Artemis 1 experiment. Please welcome Dr. Oren Milstein, CEO of StemRad. Please.
Thank you, Sharon. Thank you for having me here. It's a great pleasure. It's a very exciting period for StemRad and for the Israeli space industry in general. I was very proud that Steve agreed to participate in our experiment, and his contribution was very, very important, as I'm about to show you. So if you could move on to the next slide here. Actually, that's my job. Okay. Okay, so AstroRad is wearable radiation protection. And the purpose would be to use this when the crew members are going to venture into deep space, first of all within the confines of the Artemis program, but in the future, hopefully also private industry will take people to the Moon and beyond. In those areas, as the speaker before me underlined, you can be exposed to 2 types of radiation. It could be radiation from the sun, solar particle events, or galactic cosmic rays. Now, if you're venturing for a month or 2, your chief area of concern is actually solar particle events, because they can really, when they come in violently, they can max out your career dose within 1 event. So you won't be able to fly again. When it comes to galactic cosmic rays, to receive a considerable dose, you would have to be there for the mission to Mars, something of that nature. So the short-term or mid-term missions, you're less concerned about that. So StemRad chose to address first and foremost the threat of radiation emanating from the sun in the form of solar particle events. And for that, we made the AstroRad vest. Now, solar particle events, they can last anywhere between a few hours to a few weeks. So being in space for so long during an event requires a solution that allows the crew member to continue to perform his vital functions while trying to remain protected. One solution is a storm shelter inside Orion. And the shelter is something quite protective, however, very confining and very limiting of the ability to move around. So we came in together with Lockheed Martin. We developed this solution to allow crew members to venture outside of the confined area and do their job while they're enjoying the valuable days in deep space. So our innovation here, as was mentioned in the introduction, was selective shielding of the most vital organs within the torso region. Protecting the whole body of the crew member is quite impossible, so we chose to protect what really counts, and in doing so, diminishing significantly the likelihood of cancer down the road, or God forbid, acute effects within a very short amount of time. So here you can see on the right, you can see astronaut Jessica Watkins wearing the vest. She was our last crew member to wear the vest. This was broadcasted during the Artemis launch, so you can see the countdown and the clock on the left. And it was very exciting to see this together with my kids. This vest was a few months before worn by Eitan, and I'm going to show you a picture of that as well. Because the events can last up to a few weeks, the issue of ergonomics and comfort is really critical. It's not enough to protect. You also have to protect in a way that the crew member wants to be protected. So to analyze the ergonomics, we basically worked with 5 crew members, 4 females and 1 male, to try to determine any kind of bottlenecks with regards to the ability to move during general operations, which included housekeeping, cargo, unpacking, sleeping, eating lunch, just hanging around the crew quarters, and other more complicated things. And we found significant, but significant, meaningful limitations that we're able to overcome through quite simple improvements in ergonomics. Our way to enumerate this was to implement computer vision, to take the 2-dimensional video that we see here and turn it into a 3-dimensional figure. So we're able to accurately quantify the different limitations to movement that crew members experience throughout the duration of wearing it. So we have tens of hours, hundreds maybe of video of crew members wearing it. Here you can see Eitan wearing the vest. And I had a 1-hour conversation with Eitan. It was right before Passover kicked in. And it was a very nice conversation, I think maybe one of the first in Hebrew, with the International Space Station. And we were able to work through the different issues. Immediately became apparent that there's an issue of cross-gender suitability. Indeed, the vest that we sent up was meant for the female crew member, given that females are more susceptible to radiation. So it's basically built on the inside in a way that accommodates the specific sensitivity of females. So Eitan experienced some limitations that were unwarranted for a male, that would not exist naturally for a male version. And he basically pointed to those differences and basically confirmed our feeling that having a single product for both genders will not work well. So the key findings was that you're able to perform almost all of your day-to-day functions on station, but with limitations. And these limitations can be easily removed through basically redistribution of some of the shielding from, for example, the frontal area to the back area. We found very little limitations associated with the posterior part of the vest. So moving, shifting redistribution, and also increasing the gaps of the openings, arm openings and neck opening. And so those are the key findings. And then with regards to sizing, we found that it would be ideal, because even within the females that wore the vest, there were some 6-foot females and 5'4" females. So we found that some level of modularity is necessary within the vest. So the plan is to have one product per gender, but that product is modular by the addition and distraction of certain modules to the vest. Basically 2 modules, one to increase the length and one to increase the circumference of the vest. And now we're working on implementing those conclusions. And Eitan served a very important part in confirming something that we've been saying, and not always receptive to what we were saying. If you look at the EVA suits, they're basically a single gender solutions. But women have been complaining for many years about the need to address their specific anatomy. And we're seeing this from the reverse angle today, and we understand that not only biologically it's justified to have a gender-specific solution, but also ergonomically. And the ergonomics are critical for our product to be worn for 2 weeks. So definitely a very profound insight gleaned on ISS. And then regarding Artemis, I don't have too much time left, and actually the results are not yet ready for publication. So obviously this is going to be a peer-reviewed publication that is going to be published hopefully in a very lucrative journal. But I can tell you that we just came back from Kennedy Space Center. We were there for 10 days. We unpacked Helga and Zohar, who flew around the moon on board Orion. Here you can see them basically seated in the crew seats 3 and 4 of the Orion capsule on the launch pad. And they spent, I think, 21 days in deep space. And they came back with a treasure trove of information. I can tell you that all the detectors, all the 6,000 detectors involved worked. Okay, so for 10 days, they were reading out the data. And now in Germany, in Cologne, they're analyzing this data, and we'll have a very profound understanding of the efficacy of the vest, of the benefit that it provides for the health, in this case, of the female. The mannequin wearing the vest was Zohar, a female mannequin that simulates the human body really one-to-one. So that's it. That's all I have for you today. I hope to have more results in the near future. Yeah. Okay.
Stay for a few more minutes. Okay. You can stay. Let's turn back to the crew and ask Mike, given your extensive experience in space travel, I understand it was your fifth journey, your fifth mission. Could you tell us the importance of radiation protection?
Of course. Thank you, Shalom. And congratulations on the experiment. So to put things in a bigger context, one of the reasons that we are doing a lot of research in low Earth orbit is still to study the effects on the human body of deeper space exploration. So as is obvious now with the Artemis program, NASA and the other agencies have set their sights on going back to the moon and I think someday onto Mars. And so what we are learning in low Earth orbit can help us in developing countermeasures. So as an example, not related to radiation, I flew my last mission about 15 years ago. And when I came back after about 7 months in space, I had lost an average of 12% of my bone mass density, which is quite a lot, but average for the time. Now, due to the countermeasures that have been developed, people are coming back with sometimes no bone loss and usually within 1 or 2% of what they had pre-flight. So this is an example of a box that we have to check in order to mitigate all the risks of going into deep space exploration, and of course radiation is another very important one. So even though we're talking about solar radiation here and not GCR, galactic cosmic radiation, which is more significant if you're going onto Mars, today's propulsion would allow us to get to Mars in about 6 to 8 months there, another 6 to 8 months to get back, and based on how the planets align, about 6 months there. So you're talking almost 2 years of a mission. Today, the maximum a person could spend even in low Earth orbit with the current radiation protection is probably about 2 years, again, depending on your gender and your age, etc. And that's with a fair amount of shielding already on the ISS, and you're protected by the Van Allen belts and sort of the comfort embrace of Earth. So going on to Mars, of course, is going to need some kind of much bigger additional mitigation of the radiation risk, and I think this is a very positive step in that direction. Thanks.
Thank you. Thank you, Mike. And thank you, Dr. Milstein. Thank you very much.